In this tutorial, we're going through how to convert a number from its binary representation to its denary representation. For example, you might have to start with a binary number like this one here and ask to convert it into its denary representation, like so. We're going to work through this example starting with the binary number 1, 0, 0, 0, 0, 1, 1, 0, and we're going to work out what that is in denary. So to start off with, we have to write down the binary number. So we've got an 8-bit number, which means it's got 8 ones or zeros. I've written it out in a table with 8 columns and 3 rows. You don't have to draw the lines of the table. It might help to do so the first couple of times you try this, but you can just write the binary number as long as you leave enough space to write stuff above it and below it. So after writing out your binary number, you have to work out how much each bit is worth. So start with the bit on the far right, that's the least significant bit, because it's only worth 1, so write a 1 above it. And as you move across to the bit on the left, the bit is worth twice as much as the bit on the right, so you put 2 above it. And keep timesing by 2 every time you move to the left, so 2 times 2 is 4, times 2 is 8, and each bit is twice as much, worth twice as much as the bit on the right. So for an 8-bit number, the least significant bit is worth 1, the most significant bit is worth 128. Step 3 is to multiply the top 2 rows. So in this case, 1 times 0 is 0, move across to the next bit, 2 times 1 is going to be 2, 4 times 1 is 4, any number times by 0 is just going to be 0, so we've got another couple of zeros here, and any number times by 1 is just that number. So step 3 is multiply the top 2 rows. And finally, you just add up all of the numbers along the bottom row. So here we have 128 plus 4 plus 2 is 134. So to answer our question, the binary number 100000110 is 134 in denary.